Hello everyone, today we're going to be talking about stoichiometry.
But what do we start with if we don't know anything?
So this is why we need to start the solving with a balanced chemical equation.
A balanced chemical equation provides the same kind of quantitative information that a recipe does.
So in a cookie recipe, you can think of the ingredients as a reactant and the cookies as a product.
In the scientist's world, chemists use balanced chemical equations as a basis to calculate how much reactant is needed or product is formed in a reaction.
When you know the quantity of one substance in a reaction, you can calculate the quantity of any other substance consumed or created in the reaction.
For example, in the following chemical equation, we can see that there's a mole ratio of 3 to 2 between calcium carbonate and water.
So if you have 3 mole of calcium carbonate and 2 mole of phosphoric acid, it can produce 1 mole of calcium phosphate, 3 mole of carbon dioxide, and 3 mole of water.
The calculation of quantities in chemical reactions is a subject of chemistry called stoichiometry. Calculations using balanced equations are called stoichiometric calculations.
A balanced chemical equation can be interpreted in terms of different quantities, including numbers of atoms, molecules, or moles, mass, and volume.
For example, we all know that a mole of a compound contains 6.02 times 10 to the 23rd power molecules, which is the number being recognized as Avogadro's number.
And we also know that different elements have different molar mass, as we also look toward the periodic table.
By looking over the volume, we may also know that in the standard room temperature and 1 atm pressure, we may also know that 1 mole of any gas occupies a volume of 22.4 liters.
So when you look over this chart, it leads you to convert any units to any units that it's neat throughout the equation. Every connection to other boxes is gonna be your steps throughout your solving.
For the following example, we're looking toward the chemical reaction of calcium carbonate reacting with phosphoric acid, producing calcium phosphate, carbon dioxide, and water.
Followed by the question, how many grams of phosphoric acid react with X's calcium carbonate to produce 3.7 grams of calcium phosphate?
So for now, we know that there are 3.74 grams of calcium phosphate being produced, and the question is looking for the grams of phosphoric acid.
Refer to the chart that we have reviewed. We know that we need 3 steps to get to our answer.
Before you start with the equation, you want to find out the molar mass for calcium phosphate and phosphoric acid.
So you add up the molar mass for each element in order to get molar mass for the compound.
So we will be converting grams to mole to mole, and mole to grams. And below, here's the equation that leads us to the answer.
Just a quick reminder and tip, you always want to put the unit that you want to get rid of in the bottom of the fractions, in order of you to cancel out the unit throughout the equation.
So by solving the equation below, we get the final answer of approximately 2.36 grams of phosphoric acid.
So the last slide of this video, here are the steps and some tips that you can follow along while setting up the equations and solving the equations.
Avocado number. Oh wait, it.
Created using Powtoon.